So, a very warm welcome everyone to this short presentation, short webinar about TwinCAT IoT. So it's a short webinar because it's not the usual webinar length like 30 minutes, it's only 15 minutes in total. So because it will cover, of course, it will give you a general overview about the status of TwinCAT IoT and also give you an example for a cloud application that you can use TwinCAT IoT with. So if you have any questions, of course, there's the question window on the right-hand side of this webinar software. Just throw in all of your questions and we will answer the questions after the webinar. So there will be a short Q&A round in which we will answer most of your questions. So TwinCAT IoT is a product family, and TwinCAT IoT has been announced about 1.5 years ago on the SPS IPC Drives trade show. And TwinCAT IoT, first of all, provides easy connectivity for IoT communication. What does that mean? So basically, it means that TwinCAT IoT enables you to use public cloud services like Microsoft Azure, Amazon Web Services, or also IBM Watson, and many others. But you can also use your own private cloud system. Of course, there are some prerequisites for that, but I will cover that later. So, and you can use TwinCAT IoT to send data to one of these cloud services or receive data from one of these cloud services. So TwinCAT IoT, from a connectivity point of view, is all about standardized communication, which means you can use protocols like MQTT, you can use AMQP, and you can, of course, also use OPC UA to establish connectivity to one of these cloud services. TwinCAT IoT also has an own smartphone app, and it therefore also enables push technologies to wearable devices. So you can use function blocks within your PSC logic to send alarms to wearable devices. So this can be, for example, a smartwatch. So if you have, for example, an Apple Watch and you have the corresponding TwinCAT IoT app, which is called the Communicator app, you can receive push notification messages directly on your smartwatch from your machine. So like I said, TwinCAT IoT is a software package. It's actually a product family. And one of the first products has now also been released. So it's the TF6701 IoT communication product, which is basically a PSC library. So you can reference this PSC library within your PSC project, and then you can use MQTT publisher subscriber technologies communications initiated from within your PSC logic. So you have different function blocks available, which enable you to, first of all, establish connectivity with the so-called MQTT message broker, which can sit anywhere. It can sit in the public cloud, it can sit in the local network, so it's only a piece of software, and you can also even install it on an industrial PC if you want. So these function blocks enable you to establish a connection to such a message broker, and you can, of course, also use security mechanisms like TLS. So you have the possibility to use username and password, certificates to further encrypt your communication channel. And after that, after you have initiated your connection to the MQTT message broker, you can publish messages. So you can publish data structures, single variables, arrays, so whatever is on your mind. And you can also subscribe to data, meaning you can receive data from this MQTT message broker. So when you receive data and when you publish data, it's of course the question is what kind of data format would I like to use, right? So of course you can use the binary data format, so which is very efficient, but you can also use a JSON formats, and for this we have also implemented an own PSC library that enable and support you in JSON parsing within your PSC. So you can use regular SEX and DOM parsing technologies to handle JSON messages within your PSC logic. And this library is also available within the latest TwinCAT 3.1 release, which is built 4022.0. The next product is the IoT Data Agent, so TF6720, and it's basically an application that runs outside of the context of the TwinCAT PLC, of the TwinCAT real-time. So it's a gateway application that you install on a Windows computer and that runs totally outside and independent of the TwinCAT real-time context. So the data agent can connect to the TwinCAT runtime, and it can be TwinCAT 2 or TwinCAT 3, either via ADS, but you can also use OPC-UA. So there's an OPC-UA client implemented in the IoT data agent, which you can use to, of course, connect to the TwinCAT OPC-UA server, which is another supplement product, but you can also use the data agent to connect via OPC-UA to third-party devices. So the only prerequisite is that this third-party device has an OPC-UA server on board. The parameterization of the data agent is being done via a graphical configuration tool, and I will also show you an example for that later during this presentation. So you don't have to write PLC code for that. There is no PLC library that you have to use. You only start this graphical configuration tool, then you connect your ADS variables, so your PLC variables, with variables on a cloud service. So it can be an MQTT message broker, it can be the Azure IoT Hub, it can be AWS IoT, IBM Watson IoT, so many different options there. And then you just map the PLC variables with variables in one of these cloud services. So it's very easy to handle and a great tool to start your IoT communication. So to give you an overview about the use cases that you can solve with this TwinCAT IoT software, it's very interesting and for you to know that, of course, you can initiate from within the TwinCAT 3 PLC logic, you can initiate MQTT communication with one of these cloud services, right? So with Microsoft Azure, Amazon, SAP, IBM Watson. So, and also the Google IoT platform has also announced MQTT as a transport protocol. So you can also use the Google IoT cloud for that. And you can do that from within the TwinCAT 3 PLC logic. So, but of course you can also, in the use case of a retrofit, you can also get data and grab data from TwinCAT 2 controllers. So how do you do that? So basically what you do is you install our TwinCAT IoT data agent, and the data agent can communicate with the TwinCAT 2 system via ADS. And sample the data, sample the variables that you want to send to the cloud, and then send it to the cloud using one of these transport protocols. But of course, we have also learned that you can use the IoT data agent to do OPC-UA communication to third-party devices. So if you have a third-party controller that has an OPC-UA server on board, you can use our IoT data agent to sample data from this third-party device and send this data to the cloud. So, but we also have announced last year on the Hanover trade show, we have announced an IoT coupler, so which is the EK9160. It's an plain hardware device without any TwinCAT on board. So what you basically do is you configure it via a website. So there's no TwinCAT involved in the configuration. So you just have a website that you open. So this website is running on the device. It's very similar to from the handling, it's very similar like a Fritzbox, right? So like a DSL router, where you also have a website on the device. You just open the website from your laptop, from your desktop PC, and then you can configure the device. And what you can configure on the EK9160 is, of course, you can configure the message brokers that you want this device to communicate with. So this can be, of course, a Microsoft Azure IoT Hub. So this device is also Microsoft Azure certified. So you can configure it to communicate with the Azure IoT Hub. You can configure it for AWS IoT and for many other cloud services as well. So, and then what you do is then you can also configure the terminals that are being added to this device. So you have the device automatically scans for all the attached terminals and displays all the terminals on this website. So you can select a terminal and say, okay, I would like to have this input terminal and this channel to be published to that cloud service. So you can really grab the I/O data directly from the terminals and send it to the cloud. And of course, this also goes the other way around. So you can also subscribe to data. So if you have output terminals, like digital output terminals, you can also subscribe them to a message broker and then send commands to the EK9160 via the message broker, and then the output terminals are being switched on or off depending on the message that comes in. So it's a very interesting device, and it's very easy to handle because there's really no deep TwinCAT knowledge that the user has to have. So it's really a really good device and very, really easy handle. So to give you an example, what you can use TwinCAT IoT, or what you can use also the EK9160 with, a cloud service that has been developed by Microsoft, and it's called the Microsoft Azure IoT Suite. So the Microsoft Azure IoT Suite is basically, it's a ready-to-use IoT application. So you just start and create this application. So it can be created using a couple of mouse clicks, and then on the Microsoft Azure ecosystem, several cloud applications are being automatically deployed. So you don't need to worry about setting up a virtual machine, an Azure IoT hub. So this is all being done in the background automatically for you, and the Azure IoT Suite, the application itself then just utilizes all the different applications on the Microsoft Azure cloud, for example, the Azure IoT Hub, in order to get incoming telemetry data from the devices and then display this data on a graphical dashboard. So the typical applications for that you can currently create on the Azure IoT Suite is a remote monitoring application, and this is what we will also use in the live demonstration in a few minutes. You will have a predictive maintenance application and also an application for connected factories. So the data ingest, like I said, on this Azure IoT Suite, in this remote monitoring application, will be done via the Azure IoT Hub. So then you can use our TwinCAT products like the TF6701, 6720, like we have learned, so the IoT communication and the IoT data agent, and also, of course, the JSON library to generate the JSON messages, and then you can push data to this Azure IoT Suite application and also subscribe to data from this application. So we will see in a few minutes like this is being done in TF6701 and TF6720. So the front end for the user is a website. So it's a website dashboard which you can use to monitor your devices. So you will see a nice charting tool there. You will also see incoming alarms from the devices, so you can configure the alarms. So you can configure limits when an alarm should be raised. So there are plenty of options there, and we will all go through them in a few minutes. All right. So let's give you a demonstration about that. So if you switch to the web browser, it can be Google Chrome, it can be Firefox, and of course the Edge browser can be any web browser that supports HTML5 content. And if you navigate to http://www.azuriotssuite.com, you will automatically be redirected to this small website here, and on this website you can create new solutions. So you can create, for example, the remote monitoring solution that I just talked about. You can create a connected factory or a predictive maintenance solution. So it's really easy to set up all these solutions on the Microsoft Azure IoT Suite, and it's just a few mouse clicks, and then it takes around 15-20 minutes to provision this solution, and then it's ready to use. So what you will get then, in case of the remote monitoring solution, what you will get then is, of course, like I said, it's the device portal that you will see. So you can log into this nice dashboard here. So you can configure all of your devices. So you can configure different user credentials for these devices when you set it up. So each device needs to authenticate to this Azure IoT Suite application or to the IoT Hub behind, of course. And then you will also see metadata coming from these devices. So you can really, within a device, can describe itself and say, okay, I'm located maybe in a main building in the city Fair, country Germany, floor 2, and the street Hülshorstweg. And you can also configure like reported properties, which will be stored in the device twin of the device on the Azure IoT platform. So you can, for example, configure and send latitude and longitude of the device so that the Azure IoT Suite knows where the device is located. You can send the device manufacturer, firmware, installed RAM, processor, so many other options, and you can pretty much define them on your own, right? So, and I will also show you later how this is being done. So the next thing is that you can also configure rules. So a rule just tells the Azure IoT Suite remote monitoring solution if there are any incoming tags that should be monitored. For example, if a device sends a data field temperature or humidity, a rule defines, okay, if the temperature is greater than 42, then an alarm should be raised, or if the humidity is greater than 8, then an alarm should be raised as well, and you will see the alarms on the dashboard. So if you switch to the dashboard here, you will see the alarms here in the alarm history. So alarms are being raised here and also placed on this tabular overview here with a timestamp. And of course, you will see the live data here coming in. So you can select from different devices. So 2 devices are currently sending no data, but my laptop is sending data. So you can switch to my laptop, and you will see the temperature, humidity, and the wind speed that this device is currently publishing. So in this charting tool. So the device is currently publishing every two seconds. But you can, of course, the device itself can pretty much define on its own how fast the data should be sent. Okay, so let's see how this is being configured in one of our IoT products. For example, the TF6701, so which is the function blocks for the PLC. So if I switch now to the TwinCAT 3 PLC, this is a sample project that you can also download from our website for the TF6701. And this sample project that shows you how to communicate, first of all, with the Azure IoT Hub, but with the Azure IoT Suite in general. So what you will see here is, of course, that some parameters are being automatically created. And then the most important part is for the connection to the Azure IoT Hub is the Azure SAS token. So every device has an own SAS token on the Azure IoT Hub. And this SAS token is then being used for authenticating this device here, my laptop, to the Azure IoT Hub in order that this device is being able and allowed to send data to this IoT Suite application. So this is what happens here in the following. Of course, so the data, where is my data? My data is being created here. So I'm just creating some random data. So I don't have any IOs here at my laptop. So I just create some random data, temperature, humidity, and wind speed. I just do some calculations, and what I do then is I've created this small helper function, which then creates a JSON message of this generated data, and then this JSON message is being published using our TF6701 to the Azure IoT Hub. So let's log in. Let's see how this looks like in online view. So basically, you see your JSON document. So this is what you see here. So this data is being generated every 2 seconds at the moment, and at the same time is being sent out to the Azure IoT Hub. And this is the JSON document that I currently send up to the Azure IoT Hub. So I have also talked about the device shadow, and this is what's being done here. So I send up some device information, and I store this device information here in my string, and this is of course also a JSON message. So this is the data that you also saw on the Azure IoT Suite application. So you see the latitude and the longitude of the device, the manufacturer, the firmware, installed RAM, processor, but you can pretty much add your own properties if you'd like. So you can pretty much define your own properties. You send them up to the IoT Suite application, and then these properties are being stored in the device twin of the device and shown on the dashboard as well. And of course, as you see here, the portal itself is also secured using username and password, meaning your Windows or your Microsoft Live ID. So not anyone can see the website. Of course, they can navigate to it, but they are required to log on. And you can also define on the Azure ecosystem in the so-called Azure Active Directory service, you can pretty much define which Live ID has access to this website and which Live ID is an administrator to this website, or also only has maybe read access to this website. Okay, so this was the TF6701. Of course, we also have the data agent. So the data agent, like I said, it's a graphical configuration tool, and the data agent itself is running in the background. So you use the graphical configurator here to first of all configure your ADS connectivity. So you can also configure your IoT hub gate, so which means the device credentials, the SAS token, to the Azure IoT Hub, and then you can define the publisher. So the publisher is sending the data to the IoT Hub. So of course, then the question is what kind of data, and this is what you see here. So it's very similar to TwinCAT. So in TwinCAT, you also do a mapping between process variables, and this is what you do here too. So you have an ADS gate, you have the three variables coming from the TwinCAT system, from the TwinCAT PLC, the temperature, the humidity, and the wind speed, and then you just map them to corresponding symbols on the Azure IoT Hub gate, and then you define what data format should be used when sending these symbols. In our case, of course, it's a JSON data format, so that the website can also interpret the data. You define how fast should the data be sent, what kind of sampling mode should be used. In this case, we specified that the data should be used every 2 seconds, so which means 2000 milliseconds as a cycle time. And you can also choose a different sampling mode. So on data change, only if the variables change, the data should be sent out, or maybe by trigger. By trigger means you can define a trigger symbol, a symbol that is getting monitored, and when a limit has been reached for this monitored symbol, then the data is being sent out either continuously as long as the limit is being has been reached, or only once. So you can define different settings here. Okay, so when you're done here with the configuration, of course, you need to deploy it to the target system, and then the target system where the data agent runs. It can, of course, be also my local laptop here, or it can be a remote controller where the data agent runs. You can then just restart the data agent on the corresponding device, and then the data agent is sampling the ADS data and sending it to the Azure IoT Hub gate. All right. So let's switch back to the presentation. So, and there's only one last slide left. Do you have any questions? If so, please use the question window for now. We will now try to answer all of your questions. And if you have further proposals for future topics, maybe just let us know. Send us an email to gotowebinar@beckhoff.com. And for most current webinars, themes, dates, and records, go to www.beckhoff.com/webinar. Thank you very much. Okay, so at the moment we have one question. So the question is regarding the Azure IoT Suite application. The question was, is it also possible to use the TwinCAT OPC UA server with the connected factory solution? So if you remember that on the Azure IoT Suite website, we saw three different kinds of use cases, three different kinds of IoT Suite applications. So one was the remote monitoring solution that we used in this webinar. And the second one was the connected factory, and the connected factory is actually using OPC UA as connectivity into the factory, into the PLC in our case. And the answer to that question is yes, of course, you can also use the TwinCAT OPC UA server supplement for this connected factory solution. All right, so it seems that we don't have any more questions. Again, thank you very much for joining us to this webinar, and enjoy a wonderful day. Thank you.